Hello everyone, my name is Shrivatsa Upadhye and today I'll be talking to you about securing your AWS accounts with HashiCorp Vault. A little bit about myself. I'm a cloud developer advocate at VMware. I focus on public cloud and application security. I'm part of the Cloud Journey IO team. You can visit our website at cloudjourney.io. You can follow me on Twitter, Medium, or GitHub at iShrivats. Let's take a quick look at the agenda. Today I'll be talking about, first of all, the problem statement, the use case which we'll be addressing in this talk. And then why do we need secrets management, an overview of HashiCorp Vault, a quick look at what the dynamic secrets are, and then a live demo. And most of us are probably using Terraform or Ansible or some kind of tool to automate the deployment of applications into public cloud environments. And while doing so, we often tend to use access keys or secret keys. And these access key or secret keys are assigned to users or to roles. But in any order or any fashion, we always have to attach a policy to these users or roles. And the policy basically defines what the user can do within the system, whether they can access S3, whether they can access an EC2 resource, or RDS or Redshift or whatever you may be using. And restricting the access to users from not having admin permissions is very, very critical in cloud services. Let's say you're using Lambda as one of the services, and if you assign a permission which gives it admin access, one could ideally go and write a function which goes and creates new users and gives you access to your cloud accounts. So we definitely want to avoid these scenarios. Then we also want the ability to revoke the access and secret keys. Why do we want to do this? So there might be scenarios where you might have heard developers pushing keys to the repositories accidentally, or the access and secret keys have not been used in a long time and you don't want them lying around. So you need the ability to do that. And if you're just sticking with the tools provided by cloud providers, you pretty much don't have a lot of options, right? The only option you have is use API or go to AWS console and actually go and delete that access key and secret key, which is not scalable when you have more than 10 or hundreds of accounts spread across different cloud environments. One of the things which we could do is restricting the credentials only for a set amount of time. Let's say you built a mobile app or a web app which uploads photos and you send the photos to S3 bucket. You can have your application request a key, access key and a secret key, which lasts only for, let's say, 10 minutes, or only for the time you need the files to be uploaded to your S3 bucket. And then the keys could be deleted from the system itself. And while doing so, we could also have the ability to audit the usage of credentials themselves, right? We want to know which system, which app, or which service was trying to access the credential, and what policy was it requesting for, and when it accessed, what exactly it did. To understand what exactly it did, we can go to, let's say, CloudTrail in case of AWS, right? It has all the API call trails. But we want to understand how and which user accessed that, which user created that. And in most of the scenarios in enterprises and within organizations, you might be using Active Directory services, right? Whether you're using Okta, Auth0 or something, and you integrate with that to get the end-to-end picture. And finally, we would like to have the ability to maintain this experience across different cloud providers and also managing different kinds of secrets. When I say secrets here, I just don't mean access key and secret key. I mean your database credentials, SSH keys, or your API keys or tokens which your microservices might be using. That's all good, but why exactly do we need secrets management? Why can't I just use environment variables? So first of all, we are adopting a lot of microservices architecture today, which means there are services communicating to each other. They're maybe using API tokens or using some kind of secrets. And when you're trying to set so many of the environment variables at that scale, it gets very difficult to manage. Second, an easier technique which developers usually try to do is they hard code the secrets within the application itself, which is not a good practice. Right? Sometimes you might be contributing to open source projects and your secrets might end up there, and it can be used to perform other malicious activities within your account. And thirdly, hackers tend to exploit one of the things which developers often miss, which is unencrypted secrets and keys. Let's say you're using Kubernetes. Kubernetes by default offers secrets which are just base64 encoded. Base64 encoding is not encryption. And this is one of the main reasons for data breaches, right? Having unencrypted secrets and unencrypted data within your environment. And finally, we have teams which are working in shared public cloud environments, right? You have one environment for production where you're deploying different services, which might be coming from different teams. And you want to restrict which user can access what kind of service. And the ability to have this in a centralized place is what secrets management offers, any kind of secret management tool. So when we are talking about all of this, that's where HashiVault comes into the picture, right? It's a self-operated and a self-hosted solution. Right? It offers both open source and enterprise versions. And in today's talk, I'll be using the open source version. It provides encryption of the keys by default. And then it also provides lifecycle management of secrets, which is you can store, rotate, revoke, or expire the keys themselves. And you can also integrate with identity-based systems. So you can integrate with, let's say, GitHub or LinkedIn login by using Auth0 or Okta in the middle. So it looks at the profile, it says, hey, Shri is a developer according to GitHub, which is an external identity provider. So I'm going to allow him to access these 4 secrets, right, based on my persona. And I'm giving a full talk at HashiTalks about the same thing. It's called JWT and HashiVault in modern apps. You can check that out later. And then we also support policies. Like within Vault, you can define permissions for a particular user or system. Like I mentioned earlier, that could be based on your identity, or it could be based on the type of environment you reside in. If you're AWS only, then you will get access to AWS credentials only. And finally, HashiVault is cloud agnostic, right? It works across AWS, Azure, Google Cloud, and also with other services, like if you're using MongoDB, MySQL, or even Kubernetes, and it natively integrates with that. And this is all good, but sometimes I get questions from developers who are asking, hey, why wouldn't I use AWS Secrets Manager, let's say a native tool, versus HashiVault? And I would like to address that. So AWS Secrets Manager, as the name suggests, is a secrets management tool from AWS. It's a fully managed solution, unlike HashiCorp Vault, which you have to host it by yourself and operate it. AWS Secrets Manager seamlessly integrates with most of the native services like RDS, Redshift, and DocumentDB. If the services are non-native, if you're using some other databases, you might have to write your own Lambda function to do the key rotation. In case of HashiVault, you have to do the key rotation by using scripts. You can use their APIs or their CLI to perform the same. There's no native integration with RDS as such. But on the AWS secret side, we don't have a concept of lease period, and HashiVault offers that. With the lease period, I can say, hey, this secret expires after 5 minutes, and that's it. After that, this secret would no longer be valid, which is very critical if you remember from our earlier problem statement in large environments, right? You don't want your application secrets to be hard-coded, and neither do you want the secrets to be long-lived. AWS Secrets Manager is obviously coupled very nicely with AWS ecosystem, whereas HashiCorp Vault is cloud agnostic. It works across AWS, Azure, GCP, and other cloud providers as well. AWS Secrets Manager has very limited support for other open source tools like MariaDB, MySQL, or MongoDB, and offers minimal to no native support for Kubernetes and other kinds of infrastructure. Whereas with Vault, it has very tight integrations with databases like Influx, Mongo, HANA, as well as Kubernetes. And Vault is one of the most popular secret store used in the Kubernetes ecosystem. And finally, the cost. AWS Secrets Manager is offered only as a paid service. AWS charges you for the API calls as well as storage of every single secret, whereas Vault offers a freemium model where they have an open source version which has a lot of features, and as well as an enterprise version. If you're looking into more governance and features like that, you can look at the enterprise version. So that's great. So now let's understand what dynamic secrets are. Before that, remember, in case of AWS Secrets Manager, you have to provide static key value pairs, which is you have to say username is admin and password is password, right? And those are called as static secrets, right? And these are supported by Vault as well. But what Vault offers additional to these static secrets is something called as dynamic secrets. Dynamic secrets are not stored within HashiVault itself. They are created only when the user requests them or your system requests them, right? And it's like just in time kind of a secret generation. And that's a fantastic feature because let's say your vault is compromised for some reason, that secret wouldn't actually exist there unless the user makes a call, right? And the way user can make a call is they can integrate with your AD or OIDC, like I mentioned, external identity provider, and authenticate and authorize and only then get access. So what are the advantages of dynamic secrets? First of all, it minimizes the impact of leaky applications. So if you have set your credentials within the application, you can set them to be very ephemeral, right? You can put a shorter expiry time, and after that, the keys would no longer be valid. It also provides the ability to track down which system or user was trying to use or create this key, right? That makes it very easy to do forensics in case of any data breach that occurs within your environment. Obviously, it can do key rotation, and the way you do key rotation is by setting lease time. You can say this key is valid for 10 minutes. And after 10 minutes, you can write your own script, which can go and perform key rotation operations. And finally, you can revoke the keys. So you can say, I want to stop before, let's say, before the time expires, you want to kill the secret itself, or you want to delete the secret. That's where you would be using the revocation feature. And obviously, every time we use unique credentials, it reduces the blast radius in case of any kind of breach that might occur. So now we'll see, with the help of a quick demo, how we can use dynamic secrets to actually create AWS credentials on the fly based on the user's persona, and how we can use that to access different services, right? So let me flip between terminals, right? So here I'm trying to run Vault server, and I'll run it as in dev mode. Please do not do this in your production environment. And I will turn on debugging, right? So when I do this, I can come here, and I have a few scripts you can see here which I've listed, and I'm going to show you what exactly these scripts do. So if I come here, I can go to this AWS Vault setup script, which first of all, in the first line, uploads a policy. And like I mentioned earlier, HashiVault supports a lot of different policies, right? And on the right side, you can see the policy which I've defined. In my policy, I'm allowing the user to access any kind of secret within my system. I'm allowing the user to list the policies, and I'm allowing the user to create, update, or delete any kind of AWS credential, right? Remember here, I'm just allowing the user to list the policy, not to read it itself. And I'll show you with the demo how that works. And then I enable secrets within my environment. And I'm also writing a configuration file within which I say, hey, this is the access key and secret key for my AWS cloud, which Vault can use to create new IAM users. Remember, this is not the access key or secret key which is given to your end user as such, but this is used by Vault itself. And then I'm creating a role. I'm calling it S3 role, which is of type IAM user. You can also create an assumed role user or a federated token if you want to. And then I'm attaching a policy to it. And the policy says, I want the user to get S3 access, full S3 access, and that's all. The user wouldn't get any other kind of access. It cannot be EC2 or it cannot be RDS, right? So let's quickly run these scripts and see what happens. Before I do that, I'm going to source this file. It basically has my AWS access key and secret key. And then I'm going to run this setup file. And you can see in my logs itself on the left side, as well as over here on the right side, it says it uploaded the Hashi policy. It enabled the secrets. It has configured the root, which is basically the access key and secret key, and the role itself. And now I'm going to just verify the status of Vault. It's up and running. And I'll log in using my root credentials. So there you go. So with my root credentials logged in, it gives me permission to do anything within the system. So I can do Vault policy list, or I can do Vault policy read Hashi policy, and there you go. I can read the policy. And I can do the same even from my browser, right? I can go here to the UI and log in. You can see here, I have my AWS, my other secret store, the policies. I can even read the policy. I can edit the policy if I want to, and perform other operations, right? Let's try to create a new user and see how that would work. So in this demo, I will not be showing how we can integrate with OIDC or other systems, but I'm going to use a simple way, since I have the root access, to go create a new token. And essentially, I'm telling Vault, create me a new token based on Hashi policy, basically the policy which we uploaded. And there you go. We have the token. You can see here the token duration is 768 hours. You can obviously shrink this down. You can say it's to 5 minutes, 10 minutes, or 20 minutes. And I'm assigning it default policies, which are Hashi policy in my case. So let's do one more thing. Let me show you my AWS environment, right? I don't have any new secrets, which was created by Vault, right? It's just pretty empty, my standard users. I come in here and I can say Vault login. I'm going to use this token, and it logs me into the system, right? I also want to show you that I have not configured my AWS CLI or anything of that sort. You can see AWS S3 LS. It says it's invalid, right? And I'm going to use this token, right, which is automatically set into my environment variables to go fetch AWS credentials. I'm going to say Vault AWS S3 role. I'm going to say Vault read. There we go. Now I have access to a newly set of created access key and secret key, which gives me access to S3, right? So to verify that, I'm going to say AWS configure. Let's paste this access key. Let's paste the secret key. Going to leave them as default. Now I'm going to run the same command, AWS S3 LS. Remember earlier it had given us an error occurred, right? Now it lists all the 3 buckets which are there within US East 1. And if you go to our IAM console and just refresh this page, you'll see that it has created a new token, right? Which says Vault token S3 role. It provides me with an identifier. And I can do the same thing by logging in even from my Vault UI, right? So let me just copy the token from here, back into the system, sign in, and there we go. So I can go here. If you notice one of the things, my AWS credentials themselves are not visible, right? That's what is the ability of dynamic secret. I can create a new one. I can click on generate. And there you go. Generates, and it gives me a warning. It says you will not be able to access this information later. It's because the only thing that Vault knows is this particular lease ID, and it attaches this to the user, but it doesn't store the access key or secret key itself. What I could do is I can log back in as my root user. The reason I'm logging back as root because if within my policy, I don't have the ability for my AWS or any secrets to be revoked. So now I've logged in as root. Now I can say vault lease revoke, and let me paste the ID which we got from them. And it says revocation operations queued successfully. Let's also revoke this token which we had created from the CLI. And you will see that all of these would disappear from the AWS IAM console. There we go, it's gone, right? So that's the power of Vault. So it provides you with an ability to revoke the keys on the fly, right? And we also saw how we were able to attach policies to a particular user and restrict them from doing certain operations within the system. So in summary, first of all, remember to always rotate the keys. Right? Rotate the keys often. It's always a best practice, whether it is your database credentials or your cloud credentials, which you might be using within your CI/CD tools or with Terraform or Ansible. Right? Try to leverage dynamic secrets as much as possible because it minimizes the risk of keys being stored anywhere. And this works across AWS, Azure, and Google Cloud, like I mentioned earlier. Set vault policies to restrict access to credentials. So you don't want developers who are working only on AWS environments to have access to Azure credentials. And with the ability of policies within Vault, you can scale this across your organization. Finally, use some kind of integration like OAuth integration to improve the user experience. So your users don't have to remember tens of different login or passwords. They can just use GitHub or LinkedIn, or they can use your Active Directory login to get into Vault. And based on their role, they can get access to the secrets. And that's about it. Thank you. You can follow me on Twitter, LinkedIn, or GitHub at Shrivatsa. You can scan the QR code to visit our blog and read more about it. Thanks, everyone.